Sorry. Yet. Oh, I think we're up. Yes, here we go. I think we're up. Great. Well, welcome. Thanks for tuning in. Thanks for tuning in. Lots to catch up on. I was away last night, so I didn't get to do a session on my original schedule, but I'm back here tonight. So, and there's lots and lots to do. Let me catch you up. This little device we'll talk about. This big device, let me introduce that for people who are new to this. This is a Teletype Model 33. It's a electromechanical computer terminal designed to connect to computers in like 1963. This model, I think, dates from the late 60s. So it's about 50 years old. And it's an ASCII machine. It's got a keyboard and a printer, and it sends signals and receives signals on a current loop to whatever you connect it to, and we'll talk about that. It also has a tape punch with an on-off switch that's very mechanical. This whole thing is very mechanical. There's very little electronics altogether. And a tape reader. And the tape reader lets you, for example, connect to a machine that's a long way away. And if you have a program punched on paper tape, and it might look something like this, except it might be like a lot longer because there's only 10 bytes per inch in this thing. So like that's 120 bytes per foot, or 400 bytes per meter, or whatever. It's like not very information dense. So, anyway, if you had a big roll of paper tape with a program on it, such as an operating system or an application, then you might load it from the tape reader and say start, and it would read the stuff off the tape just as though you're typing it at the keyboard and send it down the line. So that is literally how people started their computers back in the day. We are not back in the day. We are now in the day. No, whatever. So the kind of computers I'm going to connect this to are usually modern ones. But of course, they're all connected on the internet now, so I can connect it to whatever I want. And that's the goal. Let's use this as a terminal, because that's what it's meant to be. It's like an interactive user experience, and it's for computers. Ideal for connecting to anything that has a command line. So that includes cloud services, perhaps. It includes real old machines that are still running, and there's a few of those that we can connect to on the internet. And it includes real new machines that are running, and the history of this and Unix is very closely linked, so I like connecting to Unix machines and using it as a way to learn about Unix. There we are. The latest Unix machine that I'm connecting to is this thing here, and it's manufactured by Google, and it has a coprocessor that's designed for machine learning, and it does 4 trillion ops per second at peak rate. So that is 4 million MIPS, and so it's 4 million times the power of the DEC VAX, and it's about 1 million times smaller. And it, so this is the latest local host. We almost got as far as connecting it to this thing last time. We actually, no, we did all sorts of stuff connecting to it on the system console. And when you connect on the system console, you get all of the boot messages, which turn out to be quite long. I can't even scroll back. They're way down the back of the machine. Lots of boot messages. I don't want to connect to the system console. I want to connect to a USB. And so I plugged into this one. There's a power socket, which is USB-C, and there's a OTG USB-C, and I thought, well, that's the one to connect to. And let's rewind a little. The teletype has a current loop. I built a circuit that connects it to USB. That uses a teensy microprocessor. So I have a USB thing. But I failed on the mechanical, like how do I get a USB-C to B micro connector? And I actually went down to the store and they said, have you got 2 heads or what? Because that doesn't exist. So then I came home again and I thought, oh, well, you know what? What's that? Turns out this is the OTG port. It's intended for flashing the machine and so on. This is just a regular old USB port. Well, sure, I have a regular old USB plug. Let's plug it in. So that's what we're going to do today. I have done some hacking, a little bit of hacking on this machine. I've connected to my Wi-Fi. I've cleaned up my Linux install on it and put most of the stuff that I want on there. I used to be running this on a Raspberry Pi, and now I've put most of it on there. So let's turn on the electricity for the teletype. Let's grab the camera and go focus in. Let's see. This is, so here's the teletype. Isn't that lovely? This is the box that has a Raspberry Pi that I used to connect to, and my little bit of custom electronics that does current loop to USB, and then the stacked board behind it has this teensy microprocessor on it. So I've disconnected the Raspberry Pi. It's still powered up, but this is the USB connection from the teletype. And then this here is the board. So let's just plug it in, because that should work. Fair enough. Then this is the power. Let's just plug it in. And it's powering up, and the fan spins just to warm it up and so on. So let's see what happens. The teletype chunked a little. It went chug. And, oh, this is not good. Well, it is, it's great. But I think something's wrong. But, okay, let's unplug the terminal. Actually, no, let's just turn the terminal off. The on-off switch is down here. It says off, and then line means connected to the machine, and then local means connected just in a loop to itself, so you can just type. You can use it like a typewriter. So what broke there, I think, is I set up a Getty to listen on this port so that I can get a login. And something is wrong with my Getty, so I think I should like SSH into the machine and go fix it. So I just set up the Getty like a half hour ago and I haven't tested it. And so that's what happens. I don't mind that this thing is running away with its Getty. It's a great day for that kind of thing to happen. So, all right. Shoot me questions on the chat. Anybody who's watching this thing live. If you want to shoot me questions asynchronously, then just call me on Twitter or whatever. Well, let's go fix that. Before we go fix that, I want to set something to rest here. There was somebody on Twitter said, what did they say? They were like, no, it wasn't. It wasn't something on Twitter at all. There was a thing that's quite a famous document, and it's called the Unix Haters Handbook. And it came up on Twitter, so I posted a copy of it. You can go see it on my feed. The Unix Haters Handbook was written in like the early 90s by a bunch of people who wanted to hate on Unix. And, of course, the history of Unix goes back to teletypes like this one. And so there's some snarky comments about like what a terrible experience using one of these interactively is. So I want to set something straight. One of them said the keyboard is really terrible. So the keyboard is, I'll set it to line. Sorry, I'll set it to local so that you can see what happens. The keyboard is just, it's not terrible, it's just different. Somebody said like there's a ½ inch of travel before the key goes down. Let's try this. You can, I don't have a pencil to measure. So on this old-fashioned keyboard here, you have maybe a millimeter of travel. On this one, you have to push the key a little, and then eventually it goes click. There it is. And there's a positive like feeling. You can feel that it goes click. And I don't think that's a ½ inch. I think that is maybe 8 millimeters. It is certainly not a ½ inch. So there. Zzz. Zzz. So that's the teletype authentic kind of keyboard experience. It's actually the keyboard is mechanical, obviously. Like the whole thing is mechanical. So when you press these down, then it latches a little electric connection that turns into the bits. And yeah, it's an experience. You've got to be very deliberate about pressing these things, but you can get quite a typing rate. You can get up to like 10 characters a second. You can keep that momentum going. All right, let's put the camera back. I need both hands. We'll zoom in a little bit because you want to see the print. And yeah, let's see. I want to find my iTerm, and oh yeah, I'm not connected to anything. So I can SSH to this machine, and this is the Google machine, this little dev board. Super powerful. It's a 64-bit quad-core SMP. Actually, only has a gig of RAM, and it has this amazing like coprocessor that does TensorFlow in ASIC. And of course, it's one of a class of these machines now because just this week, what's the names? NVIDIA came out with a GPU-based kind of similar platform, and again, about a teraflop of hundreds of cores of GPU on a thing the size of a little Raspberry Pi. Anyway, so I should probably be root for this. let's see if I can find what's going on with the Getty. And basically I did exactly this. So last time around, when I plugged the teletype USB into that OTG port, it literally didn't detect it. It didn't detect it in the way I hoped it would. I don't think it detected it at all as a device. And it's there's no special driver for it or anything. I mean, I went and hacked around a UDEV thinking that would fix it, and it didn't. It's like there is no special driver for it. And this is what happens when you plug it in the regular port. It's TTY ACM0. And that's exactly what it's supposed to be. So the device just works. It's like, okay. And so on the Raspberry Pi instructions, you can see some of these on the GitHub. So this is the GitHub address down here. This is the Raspberry Pi instructions, and I'm just following exactly the same these because it turns out TTY ACM0 and ACM apparently, according to my Googling, means that it should behave like a Haze modem. So it should respond to like @dial commands. Of course, it doesn't need to do that. Anyway, so I did this. I did system control stat Getty service. System CTL status Getty at TTY ACM0.service, and yeah, it's active and it's running. There is a Getty. Sorry, I'm going to switch back to the screen where you can see that thing. That looks okay. Oh, there is a piece of doc at zeropointer.de. Oh, that's interesting. Ooh. Go look that one up. So I have a Getty, and a Getty is just a process that's run by root that is saying no host name, auto login, and then whatever username. Oh, I don't really want the auto login. Maybe that's where it's failing and just throwing out a loop. And somewhere there's going to be logs for this thing. I don't know where to find them, to be honest. Let's switch back and see this systemd for administrators, part XVI, part 16, Gettys on serial consoles. And there's a whole bunch of good stuff. Hey, this is awesome. I'm going to have to tweet that link. So my result, though, was like this endless loop of stuff, and that's not what I wanted. What I actually wanted was a Getty that does a regular login. Oh, yeah, you know what? It's because, I literally pasted this thing in. Etsy systemd, system Getty, I'm going to grab that file location here. And you know what? It says auto login username, like as if I have a user called username. I don't. I have a user called ASR33. So I just got it wrong. My username is ASR33. So of course it can't log in automatically because the user doesn't exist. Now, I don't really want that anyway, so I'm just going to delete them all. Okay. Turn this thing on and it'll still be looping. But if I go here and stop the Getty changed on disk, run systemctl daemon reload to reload units. Okay, do that. Turn the machine on. Minimize this a little so you can see what happens. Start the Getty service. And I've done exactly like the Raspberry Pi instructions to make it restart automatically. It's a great day. Log in. And we're logged in. Hey. Whom? I didn't want to say whom. Who am I? By the way, that's magical still, the backspace. Who am I? ASR33. Who is logged in? Well, root is active here, so I'm just going to go exit from this, and exit from this, and go check on the terminal to see who's logged in. One user. It's been up for 11 minutes. Yum. Here we are. On TTY ACM0. There we go. So in theory, if everything is automatically set up, then when I literally power this thing on, it should prompt me for login again. So let's try it. Shut down. And the fan stopped, and the fan started back up again, so it's actually rebooted. And within a little bit, without all of the login console messages, right? We don't need to see the U-boot loader and all of that. And here we are. It seemed to miss the A, the letter A. Let's try again. Oh no! Wow. There's a little bit of weirdness here. A little bit of weirdness, and there's some timing weirdness as well. If I type something, it's doing some odd echoes. Look at this and diagnose it. I think it's doing the right thing. So one way to diagnose what's actually happening is to like turn the tape punch on. It seems to be doing the right things. Oh yeah. Well, there we are. We're up 0 minutes. We've got a brand new machine. And it has loads of disk. I put a big SD card in there so that there's loads of disk. And actually there's a whole ton of like tempfs stuff that we don't really care about. We're running Unix. Alright. Well, chip in chat and tell me what you want to do, because I have a few ideas of things that I want to do, and none of them are very urgent now. Well, yeah, I mean there's a few things, you know, but it's just a computer, and it's just a terminal, and you can't do anything too quickly because it only prints at 10 characters a second. So what are you going to do? Yeah. So yeah, I have this MMC Block 1, which is a 64 gig partition, and mounted on /mount data, so that I can put all my data on this. It turns out my 64 gig SD card is faster than the built-in flash, at least as far as I can tell, just with some DD. So yeah. Let me see. The to-do list I'm not really necessarily going to stick to. Oh yeah, I did that. Getty and SSH on the curl. I should run the Twitch bot. I haven't turned on the auto message stuff. The Python environment on here, when I copied it across from the Raspberry Pi, it didn't work the way it should have. I think because the Pi was a 32-bit machine and this is 64, so I had like, I got to rebuild Python. Dig into term iOS and STTY, we're going to do some of that, but not right now. I'm going to do auto message, and I'm going to do quick drop in the background. And this machine is so much faster than my way old Raspberry Pi. It's ridiculous. It's just fast and modern. So the Twitch bot, for those who haven't caught that stuff, is just a little Twitch bot that logs into the channel, and if you type something in chat, then it just prints it. So you can type anything you like in chat, and it'll print it out on the teletype. And that's all. There's also a pling bell command that rings a bell, because then you can get my attention anytime. So it's connected to modern machinery, right? That's the whole point of this little experiment. So feel free to just dive in there and type whatever you want, because it'll come out on the printer. So there's a few to-dos on the Twitch bot. One of them is oh, there's no tilde sign on the keyboard. I want to say my home directory, but there's no such character, so I have to say I got to do the full path. The .project file is like, what am I working on right now, historically, and Finger uses it, and I wonder if Finger is... Oh no, there is no Finger. Wow. Yeah, there was no editor on this machine either. Oh no, there was Vim, there wasn't ED. So I had to go install that. It's a funny little Unix distro. It's a it's called Beaker Mendel, and yeah, it's kind of Debian 9, or at least it seems to be, but it comes with a very strange selection of built-ins and a few Google demo things that are kind of interesting. But it doesn't have Finger. Anyway, historically, I'm not concerned. Yeah, we could install it, but I don't care. Historically, Finger was like, tell me what this user is, where their office is, and what they're doing right now, or what their plan is, and what their project they're working on. So let's go edit my project. I'm going to delete that line, and instead I'm going to append a new line that says, because I've built the Twitch bot, what's my next thing? Today I'm going to work on paper tape. Oh no! Something weird is going on. Whoa! Very strange. I don't know what. But my editor... My editor is putting new lines in all over. And that's very strange. Weird. Okay. I have some hacking to do to clean that up. I have no idea even where to start. Yeah, I did sudo apt-get install editors, or ed, I forget which, and it works okay on the SSH console. Let's just try that. Yeah, I mean that is working as you would expect. Yeah, I don't know what, but my terminal here is Xterm, so if I set my terminal to be the teletype, then I don't have colors and so on. And it seems to be like, yeah, more or less working the way I would expect. So I don't know what is up with that. There's something weird somewhere that's inserting some new lines. And I can't really tell if it's interactive here or if it's in my firmware or... Well. So, now, anyway, my project file says paper tape. My goal for the Twitch bot... maybe it's my STTY stuff, I don't know. Let's have a look. Yeah, look, I hit P and it printed out the line number. Weird. Oh. I'm at the end. Okay, I've done this. Weird. I mean, kind of interesting, but it's doing a new line between each character. If I turn this thing on, move it to the end of the line, end of the file, and it clearly did. Night mode I'm going to leave in place. So, let's look at what that actually said in paper tape land. I mean, this is like a binary debugger if you want to use it like that. This is the high bit, and this is the low bit. So if you flip it around, this is the low bit, and this is the high bit. And this is Little Indian Machine, but I guess that's a topic for another session. So let's see what it said. It said, oh, what is that character? That's a 7-7. Oh, Let's use Python just to debug this thing, and it'll tell us what's what. It would be really nice to have a phone app that reads paper tape, and maybe I could build that with the Edge TPU and all its image processing. Anyway, so this is a character binary 0111 0111, and that's a W. Yeah, so that was my W, and then this one I bet is Q. W, null. That's a carriage return. And then two nulls, because you got to wait for the carriage to return, so you have to put in a couple nulls. That's done by the teensy. And then a line feed, and then another null, because you want a bit of delay while the line feeds. So that's all done by the teensy when it gets a carriage return. And then W, Q, new line. the new line, da 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 da. It's all doing the right things. I don't know why it's misbehaving. I don't even know where it's misbehaving. Like the thing that was up here, s/etc. I think that's this code here. Let's see if this is an S, and then we'll see what's next. So if that's an S, I can't really like hold it somewhere convenient. I had a paper clip and I put it away. Right, I'm going to hold it there, and it's not quite in shot, but there you go. So I'm looking for CHR 0B 0110 1110, and that's an N. Oh, okay, this is where it says night mode teletype. That's all of that. This then is the thing before it, and we can actually see carriage return line feed, and then something, and then a little character and carriage return line feed, and then some more stuff. Okay. Huh. Okay, let's go back to this one. What is this character here? CHR 0B. So 0011, because there's 2 empty spaces before it. And then 0101. And that is a number 5. A number 5? What? I didn't even have a number 5. Oh, there was a 5268P thing, but that was... Oh, I'm confused. What's the character after it? 0B 00001101. That's a return, a carriage return. Then there's 2 nulls, then there's a line feed. Then I've got another character. Let's see what it is. 0 1 1 0 1 1 1. That's an M. So I had a 5 and an M. Well. Oh! I don't know what is going on here. I think something weird is going on here. Let's try some not weird stuff, and maybe it'll become apparent. I don't know. Oh, by the way, whoever it was that bought my latest printout of paper tape on my Etsy store, thank you so much. It totally made my day, and I hope you have a lot of fun with it. I sent you a whole bunch of the printout that I had, and you can do that too if anybody else wants to. Just like send me a few bucks on Etsy and I'll send you all the paper, because as a course of this project I end up with more paper tape than really I know what to do with. Yeah, so let's talk about that, because there's a whole set of interesting things to do with that, with paper tape, that we haven't really started yet. In this GitHub repo, there is a directory bin that has stuff, and there's an executable. It's just a Python file called pattern, and it's little Python program that is designed for punching patterns on the paper tape. And so I want to talk you through it, because then you can see all the fun we can have with paper tape. And I just made a few changes to this recently, so it has all sorts of new stuff. I'm going to swizzle this around a bit so that you see the tape as it punches. Is that going to work? Not really. How about... where's this camera gone? Zoom out a little. And... no, maybe I should just keep it zoomed in. It would be nice to zoom into the tape itself, but that means... yeah. Let's do this instead. The low-tech approach of let's actually just hold the camera in my hand, and we'll see what it does. So yeah, the paper tape punch has an off and an on button, and a release button, and a backspace button. So release means that you can then tug it and it'll pull through freely. And these buttons are actually just mechanical. They push down on these levers here. So the release button just lifts, like the whatever it is, this little wheel here that moves the tape along. The backspace button physically moves the tape back by one space, so that you can overpunch. If you want to delete things that you've printed already, then you can hit rub out and it'll go over, delete them. Then this is on and off, and these are mechanical connections to the rest of the print machinery under here that that these code bars then drive this thing. And there are little pins under here, and you can't see them right now because it's got the cover on. There's little pins in here that jump up through the tape and punch it. So what I've done in this little pattern program is there's a whole set of patterns, and there's a pattern language, and this will hopefully oh no, it doesn't work. Why doesn't it work? Let's see. Oh no, don't tell me my Python image library is not working. Really? Okay. I thought I had all my Python stuff all running. Clearly not. And yeah, there's no word wrap, so we just bang against the end of the... I'm sure it does a bit of damage, but yeah, let's install this thing and... Error! Oh, wow. So yeah, this is the problem with installing running stuff on a whole new Unix host, is nothing really works the way it should. So, let's go fix it. If I could only read that message, it would be easy to tell out what to do next. While it's doing its stuff, I'm going to turn this on, and then you can actually see this in action, right? So it is kind of cool. The paper comes off the roll, and it gets fed through the punch, and it gets punched. And the bits all get sent down a chute into... There's a little CAD box that collects them all. So yeah, we'll turn that back on when I get the image library to work. So the purpose of this this pattern thing is basically to say, let's punch fun patterns on the paper tape instead of binary blobs. And it says error, so it copied all of this stuff. That's fine. Okay, this is good. One of the things this thing teaches you is patience. How to be patient with... Yeah. So join in the chat. Tell me what you want to ask and say and all of that stuff. Because I hope I'm live. And unless you talk to me, then I can't really tell. I can't tell that I'm live, and I think I'm live. But please join in. Yeah, because I'm not. Yeah. I only have a very. Yay! Don't call me late for dinner. Thanks for joining. Awesome. I only have a very low-tech streaming machine, and it doesn't handle like bandwidth very well. And so, plus it's a 13-inch MacBook, so the screen isn't enormous either. So I'm not running like I can't see my own screen from my own machine, kind of thing. So yeah, why is Pill not working? I don't know. I did manage to install like ImageMagick, and that worked just fine. Devilish Design, welcome from the UK. Awesome. It's pretty late at night there. Thanks for staying up and hanging out. And I hope you enjoy this like vintage machinery. It's a blast. You cannot hear how loud it is. So you got to crank up the volume and really imagine the noise that goes with this thing. It's such a racket. Yeah, I'm tempted to switch back to the SSH console and debug this from an SSH pseudo terminal, but this is part of the fun of this challenge. It's like, how much do you actually want to do interactively with this machine now that all the messages are 100 million times longer than they really need to be? Okay. You know what? I'm going to do it anyway because let's race it. And it failed. And it failed with error code 1. Oh, this may be just oh, I know what it is. There is a dependency. There's a whole set of dependencies. And yeah. We have a way to go in the logs. We have a long way to go in the logs. So yeah, let's go read the doc. If in doubt, read the manual. So I'm installing Pillow, which is the modern version of Pill. It's supported on 3.7. Yes, I should hope so. Pip install pillow, that's what I did. We provide binaries for Linux for each of the supported versions in the many Linux wheel format. And, yeah, Rackham support requires librackham, Thribbity, and halfbuzz. Okay. External libraries, that's okay. And there's a ton. Once you've installed the prereqs, yeah, I should probably do this stuff. I think I already have these. I'm pretty sure that I already have these. But I can try. And I did not have Python setup tools, but that's okay. libpython arm64. This is okay. Yeah, Python dev. Oh, and then there's all, yeah, then there's all of the other dependencies, like the image processing dependencies, because it's an image processing library. So, apt-get install libtiff and my dependencies are a little weird because this is connected to the Google Debian repo. So I'm going to do this one package at a time and see what happens. There is no installation candidate for libjpeg 8. That's okay, we've already got that. Okay, so there's a little bit more stuff. If I go install too much imaging, it's probably going to break all of the Google demo. Oh, that's a bit better. Yeah, and then it needs Tickle and TK and Python TK, really? I'm surprised that Pillow requires Tickle and TK. But anyway, yeah. So moving from one machine to another turned out to be just like way more work than I thought it was going to be. Because of the weird distros, like I was on Raspbian and now I'm not. And then I'd got all these undocumented dependencies that I hadn't written down. And yeah. This is looking a bit more promising anyway. I mean, it would be really nice to run, like, some way of just, like, running everything in a portable, like a packer or something that you can just lift from one machine to another. But I'm not at that stage. And this thing is still printing. Still printing the log. Might be a while. It's lovely. And the setup is at least... it looks like it's doing the right thing this time. Because, yes. everything went. And so the JPEG dependency obviously was there, and everything is absolutely fine now. So while this is still printing, yeah. What else we got to do? Yeah. Oh, there's a few other things while it prints that I should talk about, because they're on my my open browser windows. There's this thing. Somebody wrote a terminal emulator for ASR33. So it's a little app, and it's up on GitHub. Random832, and it's a terminal emulator. And so everything comes out in uppercase, and it supports underlines by printing a new line or a character turn and then overprint. And so you can do bold in the same way and strike through in the same way. It's really awesome. And it's like wickedly complete. It limits the output to an authentic 10 characters a second. So I haven't actually tried it. I have not run it yet. I just haven't been around enough to give it a go. But it looks wonderful. And I'm very impressed that this whole project, and it's Python, so it should be understandable. Personally, I like Python. It's my favorite little language that I know, just because I know it. And what are the imports? Nothing too weird. TK, Paramiko. Yeah, wow, that's a lot of work. My goodness. I want to look at the commit history and see how long this has been worked on. There's only 2 commits. It's brand new. Yeah, like the whole thing. Bang, there we are. Anyway, it's really awesome. Please go check it out. Add any pull requests and issues. It's wonderful. So there's that. This other thing came up. Somebody pointed me at open mode for VI. And I had no idea. So there are versions of VI that support a line mode instead of a visual mode. And in open mode, this kind of line mode designed for teletypes, the editor uses a single line window into the file, moving backward and forward, causes new lines to be displayed, always like printed at the bottom, because that's, you can't backspace on this thing. And otherwise it's VI. It's like, okay, I think I need to install a specific version to get this working. And again, I've had this browser tab open, meaning to go research and go try this myself. So anyway, that's on the list. It's on the to-do, and we'll add it to the to-do at some point. I don't know if it's actually in the to-do on my on the GitHub repo. And sorry, the browser's really slow because the machine I'm running on is super slow. This is the to-do that we're editing on the terminal, and yeah, there's all sorts of stuff there. Like my to-do gets longer. That's not too bad. There's only 78 lines of to-do, but some of them I have to go redo some things we did in the past. Yeah, so I have to add that to the to-do list. But while my thing is running, and it's getting there, it's telling me what the traceback is. The headers or library files could not be found for JPEG, a required dependency when compiling Pillow from source. So yeah, we have a bit more log to get through. The thing that I wanted to go in here and talk about a little is the paper tape thing, because paper tape is wonderful and we can print patterns on it. And so the way to print patterns is there's this hey RS Senior, it is amazing clack clack, isn't it? It's just, it's it may sound quiet to you. It really isn't. Luckily I have nobody within earshot who really minds that thing. It's so noisy. I need headphones on. So yeah, in the bin directory there's a Python program called pattern that basically reads these files out of the patterns directory, and there's a little kind of syntax for how to define patterns for printing on the teletype. And hopefully the syntax is easy enough that you can like go play with it yourselves, and then I can print some stuff for you. Let me show you the simple version of this, because this is like a complex example. But here there's the pattern for a Space Invader, and it goes binary 01110000. Alright. So, interestingly, in paper tape land, obviously there's 8 bits. That's ASCII, or at least it's an 8-bit machine. And so the top one of those bits is reserved for parity, usually, so it's not being punched. When I'm just doing like text, it's none of the text uses the top bit. But then if you actually count these things, there's not 8, there's 9. There's 9 at a 0.1 inch spacing, and the 9th one is this continuous little track in the middle that is used by the reader to grab the tape and ratchet it forward. So that track is actually punched by the punch. I mean, it's a pin that executes all the time for every single movement. It's just smaller than the others. And then on the reader side, there's a little wheel that ratchets the tape forward. So when you're printing patterns on the tape, you want to have 9 bits across and just drop like the 4th one, because it's always going to have a little hole there. Whatever you do, you can't punch anything different. So it's kind of a 9-bit tape, or it looks like a 9-bit tape. So anyway, going back to the Space Invader thing, these are 8-bit values, but you can make long, wide binary values and it'll just handle it. But basically the pattern file is just a list of collections of like text or binary values. So whatever this converts to in ASCII, I don't know what that is in like text language. How long is this traceback? I'm measuring my traceback in feet now. I'm up to yeah, that's a 4-foot traceback. Oh well. Luckily I have plenty of paper. The roll is got loads of paper still on it. And paper's cheap. Yeah, you can still buy this stuff. 33 ASR was my first interface with a computer in high school in the mid-late 1970s. We used to play Trek on one during lunch, which I recorded on paper tape. Long, long gone. Yeah, so we must be nearly the same age. Because exactly that's why I have this machine here. This was my first interface to a computer in high school at the turn of the 80s. And the school I went to was a place called Ashcombe in Dorking, and it's yeah, yeah, right. It totally is. It's noise therapy. And the terminal that we had at school was up in a little closet in the back room that nobody really knew about except the math teacher. And it was connected to the Prime machines at the University of Surrey in Guildford. And hey! So TwitchBot has finally caught up. Yeah, so I want to connect this to a Prime thing at some point. Oh, so that reminds me. My other piece of news is I'm going to relocate the machine. Right now it's upstairs in my house in the media room, and it's a little too experimental for that. I'm worried if it breaks down that I'll have to carry it all the way downstairs into the basement before I can do surgery on it and so on. So there's a new makerspace in the next town over in Lynn, Massachusetts, called the Brickyard Collective, and this new makerspace has just started, and we went to their open house at the weekend, and it's awesome. And yeah, when I find this, I bought this on Craigslist. I actually had two of them, and I bought them a few years ago. I just kept my eyes open, and they turned up. And so this one is a mishmash of the two that I bought, and the paper tape I got on eBay. And this is regular, canary yellow, lightweight paper. You can tear it. It folds. It's not very strong. It smells oily because it's oiled, and it's not cheap anymore. But there's some of it in stock in places. So I have 10 rolls of it, maybe 5, at least 6 or 7. Then the other thing I have is some what I think of as deck style tape. This is paper tape. It's an inch wide. Yeah, that's about right. This is deck style folded tape. The PDP-8 and the deck series have a pretty high speed tape reader and tape punch. Nice thing about this is it says top, so you know which way is up, which is pretty awesome. But they deal with folded paper tape, and that's kind of cool. Also, it's black, which is awesome because then I could print stuff on black tape and glue it onto white or light cards to make greeting cards, and that's part of my Etsy plan. Yeah. And then the other type of tape that I have, I found this on eBay, and it was from Poland, and it's Mylar paper. It's a Mylar paper mix, and you cannot tear it. It'll punch it, but I only want to save that for special occasions, because it's going to ruin the punch if I punch a lot of it at once, because it's Mylar, so it's really heavy duty. So yeah, let me show how let's see if the paper tape printer thing works. Devilish design. I've got quite a few rolls of black, but it isn't oiled, so really don't want to use it on the Model 33. Yeah, and exactly my reasoning for the Mylar. But what's your Model 33 connected to? And I got to turn on word wrap on this thing. So let me show you what I'm doing with paper tape. If I say pattern, then this little Python script will print an Altair 8800. Beautiful, beautiful, beautiful. Yeah. I think my auto message thing is not working. Oh no, maybe it is. Yeah. Not working exactly right. Yeah, that's a classic machine. I would love to connect this to a 380Z. Back to my school days again. I also, on my shopping list, is a BBC Micro, but you can't. They're not very common in the US, so I have to get my family to ship one over from the UK or something, and then deal with voltages. So right, this pattern thing basically lets you run one of these patterns, and this pattern language describes how to punch arbitrary patterns, and I think it's like super flexible. I'm gonna turn binary to get into binary mode. And I don't know if my escape sequences are behaving properly, but binary mode should say don't escape anything. So it's a set of escape sequences that go through to the teensy that has some ANSI escape processing, and they basically say turn off all of your special automatically putting a line feed after a carriage return and that stuff. And then if I say pattern invaders, and the thing that I was looking at on the screen there was Invader 1A. So let's try it. And I've turned the tape punch on. And you can't really see that on here. Oh, you can. Yeah, you can almost see it. I'm going to tear the tape and then lift it up where you can see it. We have some Space Invaders. Aren't they good? So the binary for the I did it wrong. I should have said pattern invaders -- part invader 1A, which will just pick out this particular part of the pattern. If you just say pattern and then the name of the file, it'll print the pattern called pattern, which is 5 nulls and then 2 of an invader 1A and then 3 nulls and an invader 1B and then 3 nulls, and then it'll end with another invader 1A and then some nulls, right? So that's this line here in printed on paper tape. So that's basically the way that it kind of constructs together. The syntax of the pattern file is a little bit Python-like. Square brackets means a list of stuff. The angle, the less than greater than things are like curly braces. They mean repeat however many times, in this case 5 times, the thing here. So this means repeat twice this list of stuff here. And then anything in a string is just the name of a little pattern. Yeah. And there it is. It's a tape punch. And the thing about the teletype is you can't disconnect the punch from the print. They are wired together mechanically. They're physically driven by the same code bars. So when you get a signal in and it runs the print head, you can turn this on and off and it physically disconnects it. But you can't have the tape punching without the print head moving as well. And you can actually kind of hold one of these bars down. There's a bar called the print suppress code bar, and you can wedge it in place mechanically. You could even install a solenoid so that it had a electrical on-off, but this one doesn't have that. So anything that prints out on paper tape, you see the ASCII equivalent of it printing out on the paper as well. So, yeah. Now, the pattern that I was just working on earlier was Diamond Wave, and I've put it into binary mode, so I'm not going to get any line feeds. So there's Diamond Wave. You can see a little bit of it. It has like a forward and backward. And then there's a another one, Ribbon. And Ribbon if it works. Ribbon is really beautiful. Almost works. Oh, that's interesting. Let me show you Ribbon. If I hit the release button, I can just pull to get some clear space. Yeah. Yes. You have a paper tape reader. Yum. I would love to have like a high-speed reader and punch, because, especially a punch. I mean, if I had the industrial scale ones, like the ones you had on real computers, where, like, I forget who makes them, but they come up on eBay occasionally, and you can get ones that punch and read at like 600 bits or 600 bytes per minute instead of 10 per second. So this has a gap in it, and I think I should fix that. There was one on eBay for 700. There you go. Yeah. And now that I have makerspace space, then I have room to collect that kind of thing. And I have to restrain myself and not do that. So let's go fix this pattern. I want to fix this. There's a gap here. This pattern was actually produced by Eric on Twitter, who has a Olivetti teletype type machine, an Olivetti teletypewriter, and it's beautiful. Oh yeah, I've actually done it wrong. So I tried to transcribe his pattern, and I actually messed up there. These should be deeper spaced out. Yeah, so let's go edit the file. But my editor's a little broken. And I guess we'll just see how that goes. What's this one called? Ribbon. So, yeah, EF1J95 on Twitter had this beautiful pattern, and I tried to copy it, and I haven't quite got it right. But let me explain to you like the process for this pattern tape, so that then, if you want to make your own patterns, you can just send me a pull request, and I'll print them out for you, and then we'll see how it goes. So, yeah, this is 9 bits wide, because in theory it's easier to, you can actually see that it lines up with the dots, right? You can see how the printout matches the actual bits, and you can see where it's wrong. But I have these 2 lines here, OB 101. So that line, and actually I think that line, let's look on here. If I do it, which way around is this printing? It's printing the other way around, isn't it? Yes, with the high bit here, And let's get this back to front and right way up. It's very confusing. This is the right way, but this... I'm getting my left and right and up and down and back and front confused. It must be too late for me. So yeah, I think what I want to do is actually insert a new line. A new whole line. Not after this one. But I've got a 1100, then I've got a 101 as it starts to tear off of the edge, and there I start to move it. I think after this 1001, I want to insert another line that's a 1 and then 3 zeros and a 1, because that is where it's going wrong. So after here, go 1, 2, 3. I guess that's 4 spaces. Oh, no. Let's do some actual spaces. 2, 3, 4. 0 B. And this editor is very weird now. 1 0 0 1 1 0 0 0 1 0 0 0. Oh. Delete my mistake there. What's the next line? That looks right. I think that makes it fix. Let's try it. Pattern. Ribbon. Yeah, that's funny. This is what happens when the ribbon is not printed in binary mode. So what is happening here is it's printing, it's coming out, and it hits this thing which is actually a carriage return, and then it throws in a line feed straight after it, or something like that. Yeah, this one I think may be a carriage return. What is that? Anyway, I have to go to binary mode. And then this turns off my CRLF thing. And let's do the ribbon pattern. And without all those pesky line feeds in the way, it now looks absolutely wonderful. That is a really nice pattern. I'm very pleased. So it's not my design, it's Eric's, but it's really cute. And it's really something else. So the, going back to the, pattern, the ribbon pattern, if I can find my window to click. Let's click this one. The way this is set up, it's saying Shift 9. This Shift 9 filter or command. Hey! Hey, welcome! This is yours! This is your pattern! glad you're tuning in. This is awesome. So, yeah, this Shift 9 thing is basically a little filter function that says take all of the data that's its parameters and turn it from 9 bits to 8 by dropping out the fourth bit, so that the track gets dropped. And it has another parameter at the end, which is 0 here, which is to actually shift. So it can take the 9-bit value and shift it left or shift it right, so you can move things up and down. And that's handy if you're printing like text. So that's how the patterns work. There's all sorts of patterns. I guess I should print one that says like signing off, because I'm tired now. I'm gonna go get some food, tune out for the night. Yeah, so thanks for tuning in. This has been awesome. I've really succeeded, I think, in migrating to the new dev board, to my Coral CPU. Most things are kind of working, even though it took 2 feet of Traceback. Yeah, so I'm very, very pleased about this setup. Next weekend, my plan is to lift this thing and move it to the makerspace where its new home will be, and that means it's going to be offline. And we'll see. I hopefully will be able to get it back working and set up, and but it's going to be an adventure. I'll put it in the back of the car and drive it down the road to its new home. And the great thing about a makerspace is I can get it in front of like more people, and hopefully we'll have all sorts of passers-by come and explore and play with it, because that's really my design goal here, is to have this be an interactive, like come play with it kind of a machine. So anyway, signing off. I'm going to go back into binary mode and let's hope that works. Hey, it does. It's coming out backwards, of course. You can kind of see it there. And I'll hit the release button, pull it out a bit. And the descenders don't fit on the tape. Oh well. So thanks everyone. See you soon. Bye.